Here we are still in review mode, so we're still reviewing things that we already know. We just need to dig them out of our brains. So we're reviewing functions this time. So we're just talking about things that we already know about functions and just really solidifying. Calculus is so much about different types of functions, and we look at different types of functions and their rates of change. So it's important for you to understand what functions look like, the domains and ranges of functions, because when we start talking in calculus, there's a lot of times when we need to know if there's a domain restriction. We need to know if there's some number that we absolutely can't put into a function, because that affects the calculus that we can do. So we have to know this stuff, domain and range, which I know you guys love. So let's take a look at this. Okay, so I got to make myself smaller. All right, so remember that there's different terms. A relation is just any set of ordered pairs. So literally any set of ordered pairs that you put on a graph, it doesn't matter what, they don't have to have anything special. They don't have to follow any rules. They would just be called a relation. So a circle, an ellipse, even if I just drew a bunch of random plots on a graph, that's a relation, right? But a function is a special type of relation because it's the type of thing that it absolutely has to pass the vertical line test, which means that for each x, there's only one y. So basically, a function means if I put an x into this function machine, it only gives me out one y. And if you remember my analogy about toast, it's like a toaster, right? A function is like a toaster. When I put bread into it, I know I'm going to get toast out, right? If I put bread into the toaster, I get out toast. If I put in a bagel, I get out a toasted bagel. I know what I'm going to get out. It's not like I put bread into the toaster and I might get toast or I might get scrambled eggs, right? That's not the way a function works. A function says if you put something into this, you are guaranteed to get a certain thing out. Not two different things, just one thing out. Okay, so we'll look at what those look like. Remember that the domain is the set of all the x values and the range is the set of all the y values, meaning that like the domain is all of the possible x's that this function could take on, and the range is all of the possible y's that could come out, right? So all of the domain is all the things you can put in the toaster, and the range is all the different things that might come out of that toaster, okay? So we're going to figure out if these are functions or not, and the way we're going to do that is with the vertical line test. So we don't have a graph for this first one, so what do? Well, we just write it in slope-intercept form, so we subtract x from both sides, and we realize that this is a line with a slope of -1 that goes through the point 1, so its intercept is here, and then it goes down 1 over 1. So this is a line like that. What's the domain and range of this function? Oh, sorry, we're not asking domain and range. Is it a function? Yes, it is a function. Lines are functions, right? They pass the vertical line test. I could draw a line anywhere here, and it's only going to pass one point. If I put in an x, I always get out just one y. What about this one, though? This next one. I point to it like on my screen, like as if you can see me pointing, and then I realize you can't. What about this circle? If I put in, say, 1/2 for x, I could get out this value, or I could get out this y value, right? I could get out +1, or I could get out -1. That's not quite 1. It's 1/2 probably. Anyway, I could get out one or the other of those values, right? So if I put -1/2 into my toaster, I could get out two different things, which makes it not a function, right? Because it's just like a total crapshoot. I have no idea what's coming out of that toaster. It could be this one, it could be that one, right? And again, it fails the vertical line test because when I draw a vertical line, it touches 2 points on this on the graph, which means it is definitely not a function. Okay, the next one. Well, let's think about this. It's x squared, so the parent function is a parabola. The negative tells us it flips upside down. And the +1 tells us that it's going to move up 1. So the parabola is going to go up 1, and then it's just going to be a plain old parabola upside down. Is that a function? Yes, parabolas are functions. Actual parabolas are functions. In the next one, you'll see we talk about like a sideways parabola. But this is a function, right? Yeah, it's function. Passes the vertical line test. There's no point, like right here, you might be like, oh, does it touch 2 points? It doesn't actually touch 2 points. It gets really close to touching 2 points because it gets pretty close to being straight, but it's never actually straight. It's always increasing. Now this one, y squared equals -x plus 1. This is actually a sideways parabola. It kind of looks like this. And it is not a function because you could, you know, you could draw a vertical line and there we go. If it fails in one place, it fails altogether, right? Even if it only has one place that makes it not a function, it's always not a function. And the way I know that this is a sideways parabola is because it's a y squared thing, you know? So like anytime you see y squared, it's just a sideways parabola. Okay, so here we have two functions. We have f of x, we'll make that one our green function, and then g of x, which will make our purple function. And then it says find f of 10. Oh, well, that's easy, right? So we just take f and we just put 10 in for x, right? So we have 30 minus 1, which is 29. So f of 10 equals 29. It just means put 10 in for x. That's all that means, right? And so then this one is the same thing. It just says take the function g and put this inside of it. And you're like, but I don't know how to do that. Okay, well, let's just start with the first step, right? Take the function g and put that inside of it. So the function g is x squared. So instead of x, we have something squared, right? So then we have x plus delta x squared. Guess what? You're done. That's it. That's all you can do. I mean, like you could FOIL it out, but I wouldn't. Why would you do that? That's just terrible. You would just leave it, right? There you go. That's your answer. That's g of x. Or g of x plus delta x, I mean. Okay, g of f of x, remember this is a composition of functions. We did a fun little meme on these ones. This just means put f inside of g, right? This is put f inside of g. So f of x is 3x minus 1. So g is our outside function, right? So it's something squared, right? That's our outside function. And then inside of that, we're going to put 3x minus 1. That's it. That's the whole thing. G of f of x is that. And again, you could multiply that whole thing out. Why would you do that? That just doesn't sound fun. And then fog, remember this is the same as f of g of x. You know, because like you can almost even say it that way. You can almost say fog, f of g of x is kind of how you can see it. So the f, remember the function f is 3 times something minus 1. And we're going to put g everywhere there was an x. Well, and g was x squared. So this is 3x squared minus 1. And you notice that the 3 isn't squared because we didn't put the 3 inside of this function. We put this function inside of that function. Okay? All right. Find the domain and range of these functions. Well, first, let's just think of the graph. Okay? I know you hate curve sketching. Sorry about your luck, because we do a lot of it in calculus. So this one, remember the parent function of square root of x, just the square root of x, just looks like this. Just looks like this. That's the square root of x, right? And then this minus 1 right here, this is a transformation, and it's inside the function. It's with the x. So the same thing that's happening to the x is happening to that -1, which means it's inside the function. So we're affecting our x values. And remember, x always lies. So it looks like we would move it to the left one, but we're actually going to move it to the right one. So we're just going to move this over here. And then we didn't transform it. We didn't do anything crazy. We didn't multiply it by anything. So it's just the same old function, just like that. So what's the domain, right? What's the farthest left it goes? Well, that would be 1, right? So the domain, it starts at 1 and it includes 1, right? Can I put 1 in here? Yeah, sure I can. 1 minus 1 is 0. The square root of 0 is 0. So it comes out right? So the domain, totally legal for me to put 1 in there. And then what other numbers can I put? I can put all the way to infinity on there, right? And I'm going to put an open bracket because infinity is never included because it's not a number. And then what's the range of this value? Well, what's the lowest that this takes? Well, it goes down to 0, right? And we know that it spits out 0. So instead of an open bracket there, we're going to do a closed bracket, right? We know that 0 is included. When I put 1 in, I get out 0. So it is part of the range. And then it goes to positive infinity as well. And again, open bracket. Now, The range is easiest to find with the graph, but the domain we could have found without the graph. In fact, we could just think, remember, there are two things that are illegal in math. We cannot divide by 0, and we can't take the square root of a negative number. So we look to find the domain. We always say, like, well, what would be illegal here? Well, it doesn't have any division here, so that's not an issue. So let's just think about what would be make this a negative number, right? I cannot put something in here for x that's going to give me the square root of the negative number. That's illegal, right? So what numbers can I not put in? Well, I can't put anything less than 1, right? Because if I put in 0, I end up with a negative number. If I put in -1, I still end up with a negative number, and so on and so forth. So that's the other way to determine the domain without looking at the graph. In fact, it's faster to do it that way sometimes, but we need the graph a lot of times for the range. So, okay. The next one, this one, is a rational function. Remember, it is a fraction. And so like our parent function is 1 over x. And if you remember what that looks like, it looks like this. It's this little like thing there. Okay. And we've got asymptotes here and here. And then what did we do to transform this graph? Well, we subtracted 2 from all the x's, right? And since x always lies, that means we actually add 2 to the x's. So we go the other way. We go to the right. So we're going to move our asymptote over 2. But we didn't do anything to the y's, right? The y's stayed the same, so our asymptote stays there. And then our graph just goes like this. So let's clean that up a little bit, get rid of those parent functions. All right, so this is our graph. What's the domain? Okay, so again, we could think about what's illegal in math. We can't divide by 0, and we can't take the square root of a negative number. So what would make us divide by 0? Well, if I put a 2 in there, it would make me divide by 0, right? And that's illegal. So x cannot be equal to 2. I know that. Okay. Can x equal other numbers, though? Like, what if I put 1 in here? Can I do that? Yep. Can I put 0 in there? Yep. I can put all of these numbers, right? All of these numbers over here are totally legal. They will spit out, different numbers. Maybe they're going to spit out a tiny little fraction or even a negative fraction. That's totally fine. I just can't divide by 0. Can I put in numbers bigger than 2? Absolutely. I can put in 5 and 10 and 20. And again, they're going to spit out a fraction, but that's okay. So my domain is, I just kind of wrote that x is not equal to 2 for my own thought, but I need to make sure that I write this properly. So I'm going to write this in interval notation, all x such that x is not equal to 2. So that's my domain. What about my range? Again, we just can look at the graph and we can say what part of this graph is not included, what y value is not included. Well, this would be all y such that y is not equal to 0, because that's the only number that's not included on the graph. Okay, finally, let's look at this graph. What is the domain of this function? This I know shows up on mine as like a solid line. This is actually an asymptote. This is an asymptote. That's an asymptote. Okay. Because it looks like this is the axis, right? So they wanted us to know that that's the axis, but it's an asymptote. Okay, so what values can go in here? Well, let's just think. If I'm like walking along this graph, I could walk all the way along this graph, right? I could walk here, I could walk here, I could walk here, I could walk here, I could walk all the way along this graph. But right here at x equals 0, I can't walk on the graph anymore, right? Like there's an asymptote there and I can't get across it. Okay, so I know for sure I cannot stand on the point x equals 0 and still be on my graph, right? So that's not part of my domain. What else is not part of my domain? X equals 2 is also not part of my domain because it has an asymptote right there. Okay, so every other point on the graph I could walk on, right? Like I could walk on 1, I could walk on -5, I could walk on -1.5. All of those numbers exist on my graph. So this would be, you could, we'll just write it in interval notation, or in set builder notation, excuse me. All x such that x is not equal to 0 or 2. My pen just doesn't want to work for me today. All right, and what about the range? Every range, every number is included, right? Like I can walk on the graph, walk on the graph, walk on the graph, walk on the graph right here. And at 0, I can't walk on the graph anymore, right? So we're going to actually write this one. We'll do it in inequality notation and in interval notation. So I know that y can be less than 0, but it can't be equal to 0, right? Because there's an asymptote there. And then y is also greater than or equal to 1. All right. The other way I could write this is negative infinity to 0, comma 1 to